All right, welcome back everybody for part 2 on the color translucent shadows tutorial. So where we left off, we have just a basic projection of our object into the scene, giving kind of an illusion of a colored shadow, but things don't look quite right. And if we go ahead and just drag off an extra one here and we go to our path tracing, we can get our reference back and see that our shadow is just much too bright. So there's a couple of things that we can do. First, we can go ahead and bring back in our masked shadow. And when you do this, just as a quick side note, you're probably going to get an artifact that looks like this. This is basically its shadow acne from the scene capture, rendering the shadows. But we don't need our scene capture to render any shadows, so we are just going to get rid of that. And that will clean things up. And already we are looking a lot closer to our reference here, but we're really not there. So I'm just going to crank down the emissive strength a ton here. Pretty good. All right. In the case of the rendered view, it is probably better for me to just go ahead and exaggerate that a little bit for now. So going back to the goal here of having shadows that are blocked by objects in the scene. In order to achieve that effect, we are going to need a depth buffer, which puts us at a bit of a challenging spot, right? Because we can go into our color capture and we can tell it to capture the depth buffer, right? With scene color in HDR, scene depth in alpha. And then if we go over to our alpha and we plug this in, what we'll find is we don't have any data. Right, and the reason for that is because our colored shadow is using the show only list, right? So if we were to render all primitives, now we have a depth map, which we can use for projecting our shadows, right? And the way that's done is if you see here we have the shadow of the ground, and here we have the shadow of the sphere. We can detect the difference between those two to determine what areas need to be shadowed. But the issue is that if we use our show only list, we don't get depth. But if we use our full scene, now we're starting to pick up on the other objects in the scene that we don't want. And so, unfortunately, there isn't really a way to easily get around this with a single capture, right? Because if we look at the modes of capture we have available to us, we have scene color in HDR and RGB, scene depth in alpha. The only thing that we could potentially use is to get both depth and color at the same time, right? So all these others are either color or depth. None of them have both. So, that's a problem, right? Because we can't have that extra color being introduced from the scene. So there's probably a lot of different ways you could solve this, but I'll talk about two potential methods. One option is you go with two separate captures, one capturing the color and one capturing the depth. And that's what I've done in the demonstration I showed in the beginning. Alternatively, you could generate a mask in some other way. Like, for example, if you know what your colors are, you could use a bit mask node to grab, say, for example, grab our blue. So let's say if we do this, now we have a mask that is going to be able to blurb between shadow when it detects that the value in the blue channel is equal to 255, but in this case it still needs some cleaning up because it's catching some areas that aren't. We'd have to also test the other ones to make sure we're just grabbing pure blue. But you get the point. Basically, you could construct a mask using the data available to you and avoid a second scene capture. So if the cost of having two scene captures is a problem, there are ways to do it. Using a bit mask would not let you use the spiral blur, since that's going to cause some issues here, in that it changes the values around the edge of the mask. So those aren't really compatible. So ultimately, you can work out a different way of masking if you don't want two scene captures, but I'm just going to go ahead and proceed using the two scene capture method. It's not as expensive as it might sound because the second capture only needs to capture depth. So let's go ahead and duplicate this, and we're going to call this depth capture. We're going to parent it under our color capture. And now we need another render target. That crap is. There we go. We're going to call this RT shadow depth. We're going to go to our depth capture, grab RT shadow depth, and then on depth capture, we are going to down to our device depth, or excuse me, scene depth in R. In our color capture, we're just going to get the let's leave it at that. It's fine. So now we have a second render target here with our shadow depth. So if we go to our decal material, we can grab this. Let's go ahead and save this. Another thing we can do when we have two separate maps here, just to make this a little easier, is we can bump down the resolution of this a lot. You'll find that for our colored shadow, we actually don't need, for the color portion of it, we don't need much resolution at all, especially if we're using the spiral blur that I mentioned, which helps a lot. So let's go ahead and set this back to use show only list. All right, so now we have our shadow. That's looking pretty good. But we also have our depth. Right? We can rack, red, base color, and then depth is currently wrong because our depth capture needs to be zoomed in. There we go. Looks good. So you can see now as I move this sphere around, the depth map follows. So next thing we need to do is have a way to compare this depth to the depth of the decal, right? And so one way we can do that is by taking the distance between the world position and the position that our camera is at. So if we go to our colored shadow, we know that that distance is 300 here. But we're just going to go ahead and for now, we're going to copy its absolute location. Right? And this is going to give us the distance between any given pixel in the world and this space in the world. Now you will notice one thing, and that's that that because we're comparing to the position of the scene capture component instead of the instead of the pixel that the screen projection exists on, I guess. It's kind of hard to describe, but you'll see that this has got a bit of a curve to it. And so the way you can get around that is by testing the distance from farther away. The farther away you get, the straighter these lines are going to become. But, it's not necessarily that big of a problem. It just will be a bit of an issue when we start running our depth test for reasons you'll see in a second here. But if we go ahead and now we can compare these two values and let's go ahead and unhook our, let's just go to unlit and unhook our missive for now. So you can see we're getting something, but it doesn't look quite right. So let's go ahead and grab subtract here. And we're going to just go ahead and add a bias here. And you'll see this is the problem with having the curve I mentioned. So you can see that as it compares the shadow depths, it's not actually lining up. And so even though this is passing the shadow depth test just fine, these areas that should have kind of all come in at the same time are coming in gradually, but that's okay. So we're just gonna, like I said, if you have a problem with it, you can back the distance of the camera up and when you're doing your comparison and get a straighter line there. But this should work fine. And so now you can see that we've got a shadow mask. And as I move the sphere around, it looks good. And if I add a second sphere, looks good. So now we can go ahead and essentially use this as a as an alpha. Let's saturate it just in case for our emissive. Right? Now we are in business. So there's a couple of issues still. One, this is a bit hard, and two, it doesn't really, kind of wraps around the back side of our translucent surface here. So as far as the hardness goes, we can use a smooth step. So we'll go ahead and take this value here. Call this max. And then for now, just here. See that as I pull this up, we start to soften that shadow a bit. So improve the quality quite a lot by increasing the resolution of our shadow depth mask. So you can make that higher resolution if you need. Next, let's see. Just remember to disable any features on these capture components that you weren't actually going to be using. I'm not sure how much of that is automated, but yeah. So, all right. So already we are in a much better spot, right? We can grab shapes and we can automatically occlude here. And you can see this is from that shadow bias there. So you can find, you need to find just, if you decrease it too much, you start to get rid of your whole projection. So you want to find just the right point where you've biased it only enough to get smooth, sufficiently smooth transition, and so much so that your shadows look wrong, right? So like any shadow mapping, this has its limitations. All right, now we're still getting a bit of wraparound here. So we've smoothed things out, but we don't necessarily want it to wrap around our mesh to the back side. All right, that looks weird. So what we're gonna do next is we're gonna grab our scene texture. We're gonna grab our world normal. Grab a dot product. We need the object orientation of our decal because those are the same thing. So it doesn't really matter what the sun vector is. So if we grab this, you can see now we've got a mask that we can use to, once again, smooth step from. Call this dot min and dot max. As you can see now, we can set a range for where we want that decal to start falling off. Here, it's fine. All right, and let's go with 0.5 maybe, and negative 0.5, 0, and negative 0.5. I think that's going to be good. Make it a little sharper. 2.5. Anyway, play with it till you get something you like. But so now you can see that we have eliminated the glow from the surface of the mesh that is pointing away from the light, right? Because naturally it wouldn't be getting any of that light. All right, so we are looking pretty good here. We've got our color matching pretty closely. We've got our, let's go ahead and check things in the path tracing. We've got our occlusion in place. Look at that. So there are still some minor inaccuracies here that you could go out of your way to keep addressing. Like, for example, you can see here that with a colored translucent shadow, we still get some specularity from the sun. Whereas in our imitation here, because it's all in the masked shadow of our object, we don't get any specularity. So there are some ways around that, right? We can go back to our material and we can disable the masked shadow, and that will give us back full specularity, but we don't really want full specularity either, right? So one thing we can do is take a shadow pass switch, and we can set our opacity to be different in our shadow pass than it is in our main pass, like so. So now we've got, for example, 50% opacity on our shadow. We'll get a bit of noise this way. Let's say 75. go. So now one thing I would probably do here is we don't actually need the temporal dithering. We just want the spatial dithering. So what we can do is grab this, get rid of our temporal sample index, just take our pixel position. Now, now we are getting basically this this noise is being applied uh, as a mask and in the shadow passing. And rather than getting a fully opaque shadow, we're getting kind of a stochastically noisy shadow, and that allows us to kind of imitate the look of a partially translucent shadow here, where we still get some amount of specularity. So up to you if you want to do that, you know, either through the dither and see how this is through. Still not going to be technically physically accurate because you have too much specularity, but looks pretty good to me. So, but alternatively, you could just make it fully opaque and forgo the specularity in the shadow. So now what else can we do here? Well, we've got a depth mask, so we can imitate that soft shadowing. So again, if we go to our path tracing, you'll see that our shadow edge is pretty hard here at the bottom, and our shadow is a lot softer at the top, whereas in our imitation here, it's kind of just the same across. So in our decal, we can go and take our depth buffer, and we have this depth data, and we can use that to inform us as to how many blur samples we should take on our spiral blur. So let's go ahead and take our depth. Let's maybe divide it by 1,000. Use it as a lerp or distance. And then something higher. Basically what we're looking for is a gradient maybe we want, actually, let's grab a smooth step again. Use that. Control. All right, so here we go. Sorry about that. So here we've got smooth step dividing by 10,000. We'll go 0.25 by 0.015 for now. And what you'll see is we get actually you'll see we get a gradient, and with that gradient we can control the amount of blur on our spiral blur. I can add a lot of blur here up at the top, 0.2 maybe. But keep things a little sharper at the bottom. Now, of course, if we keep it too sharp, we bring back our jagged edges here. So we want to find a balance where it's sharp enough, 0.02 on the bottom to get rid of our edge, but not so sharp that it brings back the jaggedness. And if we make it too blurry, of course, we will start to kind of exit the bounds of our actual shadow. So you have to be careful about that as well. The only real way to combat that again is to go to your shadow depth and, excuse me, not your shadow depth, and your here we can make this a little higher resolution, and maybe continue to tweak. Tweak these values till we find something that looks good. All right. Now, if we go ahead and go to our colored glass, let's go like we did before here, and I'm just going to grab the grid texture. Maybe add a second color, just like in my example. Let's see, get that. Let's grab a custom rotator. 5. On our UVs, we're going to go 5.25. excuse me, 2.5, 0.25. All right, so now we have, you'll see here, let's go back to our shadow depth. This might make it a little more obvious when we're doing our blurring. Right, so you can see here how I can blur just the top like that while keeping the bottom relatively sharp. It should give us a pretty good match to our path tracer. Yep. You can see here, once again, sharp at the bottom, blurry at the top. And then here, got sharp at the bottom, blurry at the top. Obviously, you can control how much of that you want to introduce. But this is pretty much all there is to it. In mind that overlapping, if you want to overlap transparency, like I've done over here, and you need to make more changes. So this one, I'm just going to show you inside this material, is actually using two separate spheres. So I'm using one sphere that's rendered in the main pass, and then I'm using a separate sphere that's rendered in the translucent pass, just to give me more control over the look. So this is using a modulate shader, so you can see how this gives it, where if it's blue on blue, it's blue. If it's blue on green, it's black, to match this. Whereas if you were to try to capture this directly without the modulate, then the blue and the green. So if I go to additive here, see you get kind of a blended version of the colors, which is not how glass actually looks. So we have to use modulate. The problem with modulate is that it captures the environment behind it as well. So I'm actually using a matte. So behind this surface here, there's a matte, and this could be a sphere, so it doesn't have cut off edges, because if I go ahead and simulate here, if I were to take the shadow off, you'll see that as it reaches the edge of the matte, it turns black, because the modulate is trying to modulate against a black image, and so it can't render. But you could make a sphere. Basically, I'm rendering a plane that is also being captured along with the sphere, but you could render like basically a skybox that's white to act as a matte to capture the modulated image. You're not going to need to do this very often, because in most cases, you aren't going to have multiple layers of glass like this. But just to show some more about the things that you can do here, there's one more thing we haven't done, which is in our plane over here. It doesn't move with the sun, right? So if I go ahead and hit play, Control Shift L, you'll see that the shadow here is not moving. So what we need to do there is add some logic in our blueprint to align it with the sun direction. Now, normally you're not going to want to do this on tick because, you know, for one, you shouldn't be moving your sun on tick because then you're going to be changing the lighting, the shadow maps every single scene, every single frame, and that's extremely expensive. You'd want to set this up on a timer or something. But just for the sake of the demonstration here, we're going to go ahead and add a variable. We're going to call this sun rotation, and it is going to be BP sun object reference. Right, get sun rotation. We're gonna get actor rotation. Set actor rotation. Grab this on tick. Again, don't do this if you're in a shipped game. And now up. Broke something. That's right. We need to set the reference. So in our variable here, you can see that the sun rotation doesn't have any reference to anything. So we need to go to our, for this is the blueprint communication. So we need to go to our thing here, sun rotation, BP sun. There we go. Now it knows which sun, which blueprint to communicate with. And all right, we're still getting some bugs. Stuff always works the first time you do it, and then when you go and make a video about it, nothing works. Okay, let's see what's right here. Some these go. There we go. All right, sorry about that. Somehow, what had happened there was looking at my camera, the camera actor and the decal actor somehow got out of alignment from each other. So, all right. And then because this is happening in the events script, it's not going to line up outside of play mode unless the rotation of your sun is added to the rotation there. Okay, so one quick thing I forgot to mention, so I'm just popping back in for a quick re-recording, is earlier I showed just putting in a vector 3 for the location to compare to. You can't do that because obviously I use the camera position, so we're comparing what's the distance from the pixel to the camera, but the camera is going to move with the sun. So we need a way to pass that data to the decal. So one way that can be done is with the decal color node. So in our blueprint, whenever we're updating our actor's rotation, we are also going to set decal color. So I'm taking the color capture of this is the camera, the scene capture component. I'm getting its world location, and I'm passing that as a decal color to the target decal projection. And what that does is it just gives us the ability to change the camera in the blueprint so that when we rotate around like this, we still have accurate shadows. Whereas if we were to go to the way that it originally was, the shadows would look correct as long as we were pretty close to the original camera rotation. But if you flip around 180, then it would stop getting shadowing because it's going to have the wrong depth map for the decal. So yeah, just make sure that you have some avenue of passing through the decal, excuse me, the camera position to the decal. But yeah, here we go. You can see we've got of everything we wanted to achieve here. We've got color, and if we go ahead and just turn off the, actually I can't turn it off, but if we turn the directional light to be super low and then turn off eye adaptation here. We go to our decal material. Control the brightness in our scene here. As I mentioned, this is does have a color bounce, so you can see if I brighten the crap out of it here. Do this, you'll see that we do have a color bounce in screen space. So the one downside to this, I guess, is that if you're trying to make like a dark hallway that's lit kind of exclusively by this stuff, you're going to have some disocclusion happening, but what was that? And that's another thing here is if you change the opacity of object, because we have this set up. And then, yeah, so one thing you might run into is that if you want to have a low opacity on your glass, we see here, then it's going to reduce the opacity in the image, right? Whereas if I crank this up, then we render it. But what if you don't want the glass to be opaque. All right, so the way that you have to get around this is to take this object and then just say render in scene visible in scene capture only. All right, and then we are going to duplicate this material, or you could use a material. We'll just actually we'll delete this and then create a material instance. And we're going to duplicate our plane, make this one visible, give it our instance material. Where we will make it translucent. And then copy location. Now we can independently control the opacity of our mesh. Yeah. Now, one problem is if you do output depth, then it's gonna be visible in the scene capture and obscure the shadow. So for that, which you might want to stop the blurring, and we need to make sure we go to our depth capture and then say hidden actors, select, hide that. Name 3. Yeah. So maybe in material instance isn't going to work here because we need to be able to set that not to output depth and this to output depth. Material. And then also this one needs to not be casting any shadows. Broken. Basically, we want the one that's visible in the depth buffer. Excuse me, we want it not to be visible in the depth buffer. It's being rendered, but we still want it to render depths, and that's because if we go here and we don't output depth and velocity, you'll see we get that. If we do output depth and velocity, that looks good. But we want to make sure that that's not being captured by the depth buffer, or else it will block its own shadows. All right, now I've probably said this several times throughout the course of this video, but that is, I think, truly everything that I intend to show. So thanks again so much for watching, and yeah, have a great day.